Okay, we did the structures and the names for amides, so now we're off to the reactions. Let me rewrite this as in this form. We're trying to add nitrogen to this group and get rid of the OH off the carboxylic acid. You can see that these will go off as water. That shouldn't be surprising. And then this nitrogen hooks on. And so you just got to be careful in writing it up. So this is going to be N2H. I'm going to just write it backwards to show the bonding scheme. Then boom, boom, boom. And then water. Don't forget that, since that's an easy thing to keep track of. Now we have, this is a methylamine. And then we have 1, 2, 3, 4, butanoic acid. And so this would be, I'm just going to rewrite it as, we have hydrogen here and a hydrogen here. And these go off together. And then we just, so that's water. So we'll have a plus water, and I'm going to write it a little bit below here. What I like to do is just start from this side. And then we hook on the nitrogen, and we have the methyl, and we have a hydrogen on the nitrogen. Okay, and then we have this guy. Alright, this is easier to see. The hydrogen, this guy, go off as water. And then, so it's a condensation reaction or a dehydration reaction. We have the nitrogen here, boom, boom, boom. And three, and double check, I mean, if you're ever in doubt, should there be a hydrogen here? Well, look at this nitrogen. It has 1, 2, 3 bonds to it. That's it. That's all we need. Up here it's 1, 2, and then a hydrogen. And then here it's 1 bond to the carbon, and then 2 hydrogens, so we have it. Just like the carbon, so you should start getting used to that. Well, by now you should be used to the fact that nitrogen has 3 bonds to it rather than 4, and if it does have a 4th, which it can, it would have to be an ion, which should stand out like a sore thumb. Okay, now we've created our amide. We want to break it apart. And let me make sure I didn't skip over anything here. And that was, when we create an amide, it's a modification reaction, where we create it, and then now we want to break it apart. And we're using water, so this would be a hydrolysis reaction. Hydro meaning water, and then the lysis means to cut. So we're going to be breaking this apart, and we want to break it apart here. This is, you can see, going if you went back to the previous problem, that the carboxylic acid, we kept this part of it. We lopped off that OH and we put the nitrogen and the rest of it, the trailing part, onto it, the alkyl group. So we're going to get back to that. So what I would do, let me just write this out as, you can see that the OH is going to bond over here, creating our carboxylic acid again. And then the hydrogen here is going to latch on to that remaining half of the bond to create our amine. So, just to make sure I didn't make any mistake, I leave it in the same formation, and then just have nitrogen, and I would change that, just to put both hydrogens on the same side, so the plus. And we have heat. Okay, this one is a little different. So this is the general form. This is tough to do. What will cause just to have water add across here. That does work with a little heat, but it's easier to either do it with an acid or a base. We just got to be a little more careful. When we do this, we're going to break the bond again. We're going to create our carboxylic acid, and then we're going to create. Then the HCl will attach to this as if it were an amine, which means it's going to make that amine salt. So it does this. Create our carboxylic acid. The water, I guess we can do it this way. So the OH is going to go here. Then we're going to have a hydrogen that goes on here to create our amine, but then the next hydrogen will go on there too to create the salt. So it's a little tricky, but just when you have that HCl in there, you're going to, if you didn't have it in here, it would just be the same as this reaction, but that HCl drives this reaction forward, and we get actually, let me. This one I'm going to have to draw backwards or reverse of what is given here. Plus, and then we have the Cl minus. So it's just a combination of reactions that we've seen before. We're going to break it up into the carboxylic acid and the amine, and then we've done the amine and HCl before, which creates this. And then if we separated out the sample and we wanted to keep going, we could then just take this salt on its own and react with with base to create the original amine. Okay, or the amine that we used to create this amide previously. Okay, so we'll just stop right there. Let's go into the next one here. So we have the break. The OH group is going to go on here, and so what we end up with is actually we will create the acid, which will then react further, and it's going to create the salt, and then we'll get our amine. So it's a little trickier. So we get we have the break, we get you could think of it as the OH group adding as a carboxylic acid, but the hydrogen is shifted over to the amine, and then we're left with a salt. So if you have the amide, you have HCl, will produce a salt. Sodium hydroxide and an amide are going to produce a salt as well. So the acid is going to produce the full carboxylic acid, and the salt that is an amine salt. And then the base is going to create the amine, and then a salt that was made up from the carboxylic acid. Oh, and that's that.